Welcome to The Explainer. Ever wondered what really goes into building one of these massive AI models from the ground up? Today, we're not just looking at the finished product. We're breaking down the entire recipe, every single ingredient and technique for creating a state-of-the-art open language model.
But first, we gotta get one thing straight. What makes a language model truly open? See, it's not just about sharing the finished cake. It's about handing over the entire cookbook, the ingredients, the step-by-step instructions, everything. And this idea of radical transparency is really the heart of the model we're digging into today.
Okay, so here's our game plan, laid out just like a recipe. We're gonna meet OLMo 3, then look at its secret ingredient, the data. We'll cover the main bake, which is the training process, then the finishing touches that make it useful, and finally we'll talk about why this whole open recipe thing is such a big deal.
All right, let's get right to it and meet the star of our show, OLMo 3. Now, this isn't just another AI model popping up online. This is something different. It's the result of a massive, really intentional effort by the team at the Allen Institute for AI, or AI2, to create a completely open-source blueprint for everyone to use.
And it's super important to know who's in the kitchen here. AI2 isn't some big corporation trying to sell you something. They're a nonprofit. Their entire goal is to push the science of AI forward for the good of humanity. And that mission, well, it's the whole reason OLMo 3 was built the way it was.
Now, let's talk about what any great chef will tell you is the most critical part of a recipe, the ingredients. And in the AI world, that means one thing, data. Seriously, you could have the most powerful computer on Earth, but if you feed it junk data, you're gonna get a junk model. It's that simple.
So the OLMo team started with a truly mind-boggling amount of raw material. They collected a pool of 10 trillion tokens. A token is basically a word or a piece of a word. So just an unbelievable amount of text pulled from all over the place. The web, books, scientific papers, code, you name it. But you can't just throw all of that into the mixing bowl. The raw data has to be carefully prepped. So they built this whole data cleaning pipeline. First, they got rid of all the duplicates. Then, and this is crucial, they scrubbed it of any personally identifiable information. After that, they filtered out all the low-quality junk, and finally, they did something really smart. They strategically decided to use more of the highest quality data. And that whole process, especially that last part about quality upsampling, boils down to a super simple but powerful idea. Use more of the best stuff. If you want to make a really smart model, you have to feed it more of your smartest, highest quality text.
And this chart right here, this shows you what that final ingredient list looked like. You can see it's not random at all. The team deliberately boosted certain categories. Just look at how much they favored science, math, and tech, and software development. This wasn't an accident. It was a strategic move to build a model that's incredibly good at those really complex subjects.
Okay, so the ingredients are all prepped and in the bowl. Now it's time for the main event, the bake. This is the training phase, and it's where all that curated text is used to forge a complex digital brain. And we're not talking about your standard kitchen oven here. This is like a digital blast furnace. I mean, the training ran on 128 server nodes, and each one of those was packed with 8 of NVIDIA's top-of-the-line H100 GPUs. This whole stage was so intense, it ate up over 90% of the entire project's compute budget. Just wow. But get this. Even after that massive initial bake, they're not done. The model then goes into a mid-training phase. You can think of it like a second, shorter bake designed to really hone specific skills. They use these smaller, specialized data sets to make the model particularly great at things like complex math or writing code.
Okay, now this is where the team got really clever. How do you know if a new ingredient is going to improve your recipe without risking the whole batch and wasting a ton of expensive computer time? Well, they use this technique called microanneals. These are like quick, cheap, mini training runs to taste test new data and see if it makes the model better before they commit to a full bake. It's genius.
So, the base model is baked. It's incredibly smart, it's packed with knowledge, but it's not a helpful assistant yet. Now it's time for the finishing touches. You know, the frosting and the decorations that turn this raw engine into something you can actually have a conversation with. This finishing process actually gives us two distinct flavors of the model. On one hand, you have OLMo 3 Think, which is fine-tuned for tackling really complex, difficult problems. And on the other, you get OLMo 3 Instruct, which is designed to be your fast, friendly, general-purpose assistant for everyday chats. And this gets to a really fundamental question, right?
How do you take a model that's basically just a superpowered autocomplete, it's only been trained to predict the next word, and turn it into something that can actually follow instructions and be a useful assistant?
Well, it's another three-step recipe. First up is supervised fine-tuning, which is basically like making the model study thousands of examples of high-quality conversations. Then comes preference tuning, where you show the model two different answers and teach it to pick the better one, so it starts to develop a sense of quality. And finally, there's reinforcement learning, which is like giving the model a reward every time it generates a great response, sharpening its skills through practice.
And the team found something really fascinating during this process. They discovered that teaching the model to just be more concise during that preference tuning stage actually made the final reinforcement learning step much more effective. In other words, getting it to give shorter, more to-the-point answers gave the model a better foundation for that final polish.
And sharing little discoveries like that one is exactly what this project is all about. It brings us right back full circle to where we started, this core philosophy of a radical, no-holds-barred commitment to openness.
And when the OLMo team says fully open, they are not messing around. They didn't just release the final models. They released the entire 5.9 trillion token training dataset. They released all the model checkpoints from every single stage of training. They released their evaluation tools. They released all the code. They literally handed over the keys to the entire kitchen.
Now, this level of transparency is incredibly rare in this field. So it makes you wonder, what does this actually mean for the future of AI? What happens when you don't just share the final cake, but you share the complete, unabridged recipe for how to bake it from scratch?
Well, for starters, it completely demystifies the whole process. By cracking open the black box, it lets the entire global research community finally inspect how these massive systems are built. They can pinpoint which data might be causing a weird behavior, they can understand why a model fails at certain things, and they can all work together to build safer, more capable AI for everyone.
Ultimately, what the OLMo 3 project really is more than just a new AI model. It's a statement. It's a comprehensive open-source toolkit, an invitation to researchers and developers everywhere to stop being just consumers of AI and to start being co-creators, helping to bake the future of AI together.